Today we're going to continue practicing solving systems of linear equations using the substitution method. So let's get started. With this example, we're asked to solve the following system by substitution. So our system consists of two linear equations written in standard form. And to solve by substitution, the first step is to rewrite one of those equations in terms of one of the variables. So what we'll do is take any one of these variables and we're going to solve for that variable. And when we do that, the result will be rewriting one of the equations in terms of one of the variables. So you can pick any of these. But what I look for is one with a coefficient of either 1 or negative 1. So I'm going to solve this second equation for y. So we have 5x minus y equal to negative 11. So solving for y, first step is I'm going to subtract 5x from both sides, resulting in negative y equal to negative 5x minus 11. We now have a coefficient of negative 1, so let's divide everything by negative 1. That will cause all of these signs to change. So we end up with y equal to 5x plus 11. Next step is to substitute that equation into the other equation. So we solve for y in the second equation. So now we're going to replace the y in our first equation with that value. So the first equation is 4x plus 12y equal to 4. Wherever there's a y in this equation, we're going to replace it with, or substitute it, with 5x plus 11. So this is 4x plus 12 times 5x plus 11, all equal to 4. We've created a new equation, and this equation has only one variable in it, the variable x. So now we can solve this new equation and find the value for x. So this is 4x plus 60x plus 132 equal to 4. We're practicing our multiplication tables here. Combining like terms, we get 64x plus 132 equal to 4. And now we want to solve for x. We're going to get the x all by itself, so we're going to subtract 132 from both sides. This results in 64x equal to negative 128. And then dividing both sides by 64, we get 1x, or x, equal to negative 2. So now we're going to find the value of the other variable, the variable y. And you can do this by plugging in this value for x into either of these first two equations that we had at the start. But I like this one that's already in y equal to form. So I'm going to take this negative 2 value and plug it in where there's an x. This gives us y equal to 5 times negative 2 plus 11. We have y equal to negative 10 plus 11. And this is y equal to 1. So our solution is the ordered pair, negative 2, 1. Now let's check that answer. So we're going to take that first equation, 4x plus 12y equal to 4. Wherever there's an x, we'll plug in a negative 2. Wherever there's a y, we'll plug in a 1. We should end up with a true statement. So this is negative 8 plus 12 equal to 4. And then negative 8 plus 12 is 4. So we have 4 equal to 4. That is true. So that ordered pair is a solution to the first equation. And we're going to do the same with the second equation. So we have 5 times negative 2 minus 1 equal to negative 11. This is negative 10 minus 1 equal to negative 11. So we have negative 11 equal to negative 11. The solution to this system is the ordered pair, negative 2, 1. As a quick review, when we solve systems of linear equations, the most common methods to use are the graphing method, and that's where you graph the lines and you see what's going on. And then there are two algebraic methods. And these two algebraic methods are commonly called the substitution method and the elimination method. But sometimes the substitution method is called elimination by substitution, and then the elimination method is called elimination by addition. Because when we're looking at both of these algebraic methods, the goal is to temporarily eliminate one of the variables. So you may see substitution written as elimination by substitution. And typically when you're solving systems of linear equations, you're going to pick one of these two elimination methods. The graphing method is valid, but it can get quite tedious, particularly if the solution set, that ordered pair, isn't integers. But unless told otherwise, you can choose one of these two methods. But for this lesson, we're going to continue looking at the substitution method, or elimination by substitution. So with this second problem, we're going to solve the following system by substitution. We have 5x minus 7y equal to negative 16, and 2x plus 8y equal to 26. That first step is to rewrite one equation in terms of one of the variables. Again, you can pick any one of these four variables and solve the equation for it. If one of the variables has a coefficient of 1 or negative 1, I will typically choose that variable and solve for it. But we don't have that in this problem. We have coefficients of 5 and negative 7 for the first equation, and 2 and 8 for the second equation. Again, you can choose any of these variables, but how I decide is I look at the divisibility of these numbers. So in each equation, I'm going to take the smallest one, so in the first equation that is 5, and ask, are the other two numbers divisible by it? So when we're talking about divisibility with mathematics, that means we can divide by a number and end up with no remainder. So 7 is not divisible by 5, and neither is 16. But this second equation, both 8 and 26 are divisible by 2. So I'm going to solve this second equation for x. So we have 2x plus 8y equal to 26. So to isolate the x, first step, we're going to subtract 8y from both sides. This results in 2x equal to negative 8y plus 26. And now I'm going to divide by 2. So that's why I was checking divisibility. I'm going to divide all these terms by 2. We end up with x equal to negative 4y plus 13. Now I checked for divisibility because I wanted to avoid fractions. So now we're going to substitute that equation into the other equation. So this is 5x minus 7y equal to negative 16. So where there's an x, we're going to substitute negative 4y plus 13 minus 7y equal to negative 16. This is negative 20y plus 65 minus 7y equal to negative 16. Combining like terms, we get negative 27y plus 65 equal to negative 16. Subtracting 65 from both sides, we end up with negative 27y equal to negative 81. And then dividing both sides by negative 27. This is y equal to 3. Now we have to find the value for x. So we'll take y equal to 3 and plug it into this equation. We have x equal to negative 4 times 3 plus 13. So x is equal to negative 12 plus 13. X is equal to 1. We have the ordered pair 1, 3 as our solution set. Let's check our answer. So this is 5 times 1 minus 7 times 3 equal to negative 16. We have 5 minus 21 equal to negative 16. Negative 16 equal to negative 16. So that is a solution to the first equation. For the second equation, we have 2 times 1 plus 8 times 3 equal to 26. 2 plus 24 equal to 26. We have 26 equal to 26. That is also a true statement. Let's practice one more. So we're going to solve the following system by substitution. First equation is 9x plus 3y equal to 12. And the second equation is 2y plus 6x equal to 10. Now I kind of say first equation and second equation, but this order does not matter. But the first step is still to rewrite one equation in terms of one of the variables. I first look to see if I have a coefficient of 1 or negative 1. I don't, unfortunately. Next, I'm going to check divisibility. So in this first equation, the smallest coefficient is 3, and 3 does go into both 9 and 12 without leaving a remainder. So solving for y in this first equation would work, as would solving for y in this second equation, as both 6 and 10 are divisible by 2. So either of those strategies would work. I'm going to go ahead and just start with this second equation and solve for y. So we have 2y plus 6x equal to 10. So to solve for y, the first step will be to subtract 6x from both sides. This is 2y equal to negative 6x plus 10. And then we'll divide everything by 2. And we end up with y equal to negative 3x plus 5. So we have rewritten this second equation in terms of the variable x. So now we're going to substitute this second equation back into the first equation. So we have 9x plus 3y equal to 12. So 9x plus 3 times the quantity, negative 3x plus 5. And always rewrite this substitution step. Don't try to do this in your head. We'll then simplify down this left side. We have 9x minus 9x plus 15 equal to 12. And then we're going to combine like terms. 9x minus 9x, that's 0. So we end up with 15 equal to 12. So we've gone from two variables in the original problem. After substitution, we were able to eliminate that y, so we now have an equation written in terms of x. But then when we simplify down that equation, we've lost all of our variables. And we have a statement, 15 equal to 12. Is that true? No, that's not a true statement. So since 15 is not equal to 12, since that is not a true statement, that means that this system has no solution. What that means is we have parallel lines, and those equations do not represent the same line. As a quick check, if you'd like, you can rewrite both of them in slope-intercept form. So here's the second equation in slope-intercept form. So let's quickly do the first equation in slope-intercept form. So we have 9x plus 3y equal to 12. We're going to subtract 9x from both sides. This is 3y equal to negative 9x plus 12. And then dividing by 3, we get y equal to negative 3x plus 4. So these two equations, they have the same slope, slope of negative 3, but a different y-intercept. So in this case, we have parallel lines, and these lines do not represent the two equations we have here. So as we're solving a system of equations by substitution, if we end up losing all of our variables, and we end up with just one number equal to another number, if those two numbers are not equal, like we have here with 15 equal to 12, That means we have no solution. The two lines are parallel to each other. If we end up with a true statement, let's say we did this problem, we ended up with 12 equal to 12, so a true statement, that would mean infinitely many solutions. The two equations represent the same line. A great way to learn is practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. So for this first problem, I went ahead and solved for x in this first equation. So we have 6x plus 6y equal to 0. Solving for x, we end up with x equal to negative y. We then plug this value of x into the second equation. And then solving that equation, we end up with y equal to 2. And then with a y value equal to 2, we can then substitute that back into this equation. And we get x equal to negative 2. So our solution is negative 2, 2. An x value of negative 2 and a y value of 2. And then check your answer. And then for this second problem, solving for y in either equation would be a practical first step, and there wouldn't be much of a difference if you chose one over the other. I again just chose this first equation, the 6x minus 3y equal to 18, and solve for y, ending up with y equal to 2x minus 6. From there, I plug this value for y into the second equation, and then after solving this equation, ended up with x equal to 1/2. So this resulted in a fraction, and then this value for x, this 1/2, was plugged back into this equation, and we end up with a y value of negative 5. So we have the ordered pair, 1/2, negative 5. And make sure you check your answer. Drop any questions you have in the comments. Continue practicing solving systems of linear equations by substitution, and I'll see you in the next video.